This section's on 7.1, integral of net charge. So this is actually the opposite of what we did in Calculus AB in Chapter 3. We found the velocity and acceleration, and that required the derivative. In this case, we're going to find the displacement and also total distance, which require integration. So let's talk about as the particle. So when a particle is moving to the left, to the right, and also stopping, we're going to graph the equation out just like this, and it's going to determine then from the left-hand side, right hand, and also stopping. But it really can't determine at this point. So what you're going to do is you're going to take the graphing calculator, move it 90 degrees to the right-hand side, and it's going to flip over something like this. Now this is the x-axis still that we have, and this is the y-axis that we have right here. So now the left-hand side is anything that's less than down here, and anything on the greater hand or the right-hand side is going to be the greater side, and then anything that's stopping is that's crossing on the x-axis. So we're using the x-axis as the reference point for the left hand, the right hand, and also stopping. More definition, it's displacement. It's a change of position when x equals a to x equals b. So we're going to take this equation and we're going to say from a to all the way to the b right here. A right here, the area is positive, and all of this is now negative. So we're going to consider both the positive and negative of the area. So when we set this up, it's going to become the integration from a to b of vt. The other one is going to be the total distance. Now total distance is still from A to B, but in this case, the bottom part right here, that's going to be flipped up, and now we're going to have it on the top part, and you're going to set it up as an absolute value instead, because we're finding the total distance of something. Okay? So now let's take an example. Let's graph this out. And when you graph this out, we're going to go ahead and find the left-hand side, the right-hand side, and when it stops. So using the graphing calculator, making sure it's flipped over. The left-hand side is from here to this point right here. So on the graphing calculator, you're going to have to find the zero. So second calculate 0 to figure out what that point is. And then same thing right here. Second calculate the 0 to figure out what that point is. Okay? So the left-hand side is between 1.4 and 3.6. So all of this right here is the left-hand side. Now the right-hand side, we're going to consider it from 0. So from 0 to this is all of the right-hand side, so that 1.4. And then from 3.6 on, this is also the right-hand side. The left part, or the stopping part, is where it crosses on the x-axis. So it's crossing right here, it's crossing right here, and the other part will be the negative if we consider the negative. So you may have to look at the restriction of the problem. If it considers the negative, you're going to use the negative, but it considers from 0 to infinity, then you're only using the positive numbers. Okay? So let's go on to part B. Part B is finding particle displacement when s is equal to 0. I'm sorry, s0 is equal to 3. What is the particle's finest position? So we've actually seen this in Calculus AB. When we take the integration of something, we can consider the initial condition. So that's what that is right there. So we have to include the initial condition after the calculation. So as we mentioned before, the displacement is from A to B. So we're setting this up as the integration from A to B of that equation right there, right? And we're going to get a negative 2.2176, which makes sense because the area of this right here is positive, but all of this is negative, and there's more of this negative versus the positive, so that's why you're going to have a final answer is a negative. But we also have to include as the initial condition, so in our calculation, so we're going to add it to the 3, and then the final answer comes out to 0.7824. Part C is asking us to find the total distance of that same graph. So total distance, again, we said was positive. So we're going to take all of this, we're going to flip it to the top. When we set it up as a calculation, it's an absolute value. So the absolute value of that equation right there comes out to 10.823. Notice it's large on that 10.823 because we had to do all of this right here is the positive, whereas displacement, consider that as a negative. Okay? So that's going to be the classwork for this section on 7.1.